Hello everyone, thanks for joining this video. I know this isn't ideal, but we're going to try and do our best with this and get as much as we can. The intention is for these videos to be fairly short. I'm going to have probably 3 or 4 videos for this one note packet. You can skip through them if you're feeling like you know what you're doing. They're just designed to help you understand the material without me actually being there. I will also just post the answer key along with these, so if you want to just look at the answer keys, feel free to look there. This first video is really just a review of what we did last week or 2 weeks ago before we went on spring break. So I feel a lot of you may be able to skip over this and go on to the next one, but it's just going to be a review of what an exponent is, right? So we start off our exponent functions, our f of x equals b to the x, where you have a base and an exponent. Next thing to remember is our set of exponent rules off to the side here. These are really just all the working tools that we're going to have as we work through there. Paying close attention to 1, 2, and 3. Those are going to be the ones that we use the most. 6 and 5 kind of come up a bit. 4 we've been using most of the semester, but it's not as necessary whenever we're reviewing these exponents. The other thing we talked about was, because this is a calculus class, taking the derivative of a general exponent rule, as we see up here with this base of b, is not always the easiest thing to do. So we will traditionally be working with a function f of x is equal to e to the x. Right? And that will be where we spend most of our time, most of our lives, working with that function there. We call this function the natural base, and just because e is considered a natural number, because later on when we talk about derivatives, it's really nice. All right, so to kind of get a nice little expression or get a nice little work on what this looks like, let's look at how to simplify or condense some of these exponents, right? So in this first example we have here, we want to make this as a single base, right? So only one e left. The first thing I'm going to do is apply that third rule to this highlighted part here. So what that looks like is we get this first part stays the same, e to the 2x times e to the 6x, because that third rule tells me we multiply our exponents together and we take a power to a power. And we're still divided by e to the 7x. All right, our next piece, kind of working with over to the side here, we're going to add these two exponents on the top. E to the 2x times e to the 6x is going to give me e to the 8x, still divided by e to the 7x. All right, we're going to finish this problem off. Sorry, I'm trying to work with the smallest area I have. This will become e to the 8x divided by e to the 7x. We subtract our exponents using that second rule, leaving us with just e to the x as our final base. I'll leave that second problem for you to try here. All right, like I said, I will be posting an answer key as well. You can maybe I've already just skipped straight to that if you want to check out that answer. Now, the reason why this is so nice, what's so convenient about this is when we take this derivative, it's really nice and easy, because if I have some function y is equal to e to the x, then the derivative y prime is e to the x. Right? Nothing really changed there. Our function stayed the same, and we had the nice derivative. Now what we can do to add some complexity to this is our product rule. So if we remember, this has been a while, our product rule tells me if I have y is equal to f of x times g of x, my derivative y prime is the derivative of f of x times our original g of x plus the derivative of g of x times our original f of x. All right, and that's a nice formula that we were supposed to memorize, but we kind of ran out of time for the last test, and we just kind of are working with it as well as we can. The next piece was the quotient rule. What the quotient rule tells us is if similar ideas, if we have y is equal to f of x divided by g of x, then we can take our derivative, y prime, as the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, all of that divided by the denominator squared. Okay, so let's try and work with some of these derivatives. So let's look at this first problem. I'm going to go ahead and write our product rule at the top here so that we can have it with us as we use it. All right, we're going to get f prime of x times g of x plus g prime of x times f of x. All right, and let's find each of those pieces as we work through this. Okay, so to start with, our first function, f of x, is going to be this first part, e to the x. Our second function, g of x, will be the second part, x squared plus 2. All right, now let's take each of those derivatives. F prime of x is the easy part, right? Because the derivative of e to the x is e to the x. The derivative of this quadratic over here will be 2x plus 0, so we just have a 2x. All right, so now we just plug all those pieces in. We take f prime of x, which is e to the x, times our original g of x, plus g prime of x, times our original f of x. Now you can get fancy, and you can factor out this e to the x if you want to. What we have here is a perfect answer, but you can factor this out, getting us x squared plus 2x plus 2, just to make our answer a little bit neater. All right, I will leave this other problem over here for you to solve on your own. All right, I will leave an answer key if you'd like to check those at some point. All right, so go ahead, look at this highlighted answer. This highlighting is not very good, but will work for you. All right, so the next thing we're going to talk about is the chain rule, and I'm going to use this chain rule specific to our function e to the x. Now this doesn't work. This isn't the chain rule for every function, but it is very specific to what we're going to be using this section. All right, so when I say specific, that means the function we're dealing with is something along the lines of y is equal to e to the g of x, right? We have some function in this exponent up here, right? We have a g of x up top that we're working with. Now what we can see is that our derivative, y prime, is going to be our original function, e to the g of x again, right? So you're going to completely repeat your original function, but then we have to multiply the chain rule piece here, multiply by the derivative of that exponent function, right? So notice when we take that derivative, this piece here is the derivative of your exponent. All right, let's try this out in practice here, right? So if we look at this function here, we have e to the g of x, where our g of x is 3x squared plus 2x minus 6. Right, so the only piece of information we're going to need from this above piece here is our g prime of x. Right, we're going to have that in order to find the answer. And luckily this is just a polynomial, so our g prime of x is just the application of that power rule. So we get 6x plus 2. All right, which tells us overall that our y prime is going to be equal to e to the 3x squared plus 2x minus 6. Notice it's the exact same as our original y. Right, but then we're going to counteract that chain rule by adding in, or multiplying, I should say, 6x plus 2 by that derivative we had above. Again, I'll leave this other problem for you to try on your own. Now, for some conclusions, some things that we just kind of would like to know in the end is if we have a function y is equal to e to the x, our derivative y prime is e to the x, right? And then we expanded on that with if y was e to the g of x, our derivative y prime was e to the g of x times g prime of x. All right, we had our product and chain rules in there as well. I'm not going to rewrite those. Sorry, product and quotient rule as well. Please check back for those if you want to check those. All right, but that was a nice, I know it's a little bit longer, about 10-minute recap of what we did last week. Now, for the future, I'm going to try and make these videos around 5 minutes. I've tried to curate them to be one topic per unit. I'm not doing a lot of extra practice. All right, but there will be an answer key available if you want to try those extra problems that are in there. Try those on your own and then check your answers to those answer keys. I would really recommend that. And also make sure you're checking the homework assignments that we're doing throughout the week. That's going to be where most of the practice and learning comes in, right? Working through these on your own. All right, see you guys next time.